We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live, streaming in real time around the globe.
Previously, we explored 3I Atlas, the third interstellar visitor to our solar system, traveling at a speed of 60 kilometers per second. Recently, the extreme distance and unusual chemical composition observed by the Hubble and James Webb Space Telescopes could pose either the greatest threat or the most significant opportunity humanity has ever encountered, challenging all our understanding of the universe. If we can decode the secrets it carries, we might, for the first time, collect interstellar dust particles containing organic compounds. This is the first direct evidence of life's building blocks traveling between stars. Harvard professor Avi Loeb suggests this object may be a harmless interstellar meteor, while many others fear it could be a technological product of an extraterrestrial civilization. Now, scientists are outlining the Interstellar Comet Explorer, a mission designed to one day chase these cosmic wanderers. A mysterious object called 3I Atlas is speeding into our solar system right now, and it could hold secrets that shake up everything we know about the universe. This visitor comes from deep space between the stars, so it stands out from the usual comets that orbit our sun, and it follows a path that means it will zip through without ever coming back. Scientists call it an interstellar object because it formed around a different star long ago, and now it carries clues about distant worlds we have never seen before. People first noticed this traveler in early July 2025 through a telescope system in Chile, and it marks only the third time we have confirmed something like this entering our neighborhood. The first one was Oumuamua back in 2017, which looked like a cigar-shaped rock and sparked wild ideas about spaceships, and the second was Borisov in 2019, a comet that released gases as it passed by. But 3I Atlas moves at about 60 kilometers per second, which is faster than most things in our system, and its orbit has an eccentricity of 6.14 with a steep incline of 175 degrees going the opposite way from our planets. That speed and angle show it got flung out from its home star system, perhaps by a close brush with a giant planet or some explosive event, and experts estimate it might have started its journey over 1 million years ago from near the busy center of our Milky Way galaxy. This arrival feels like a rare chance to learn about how other solar systems build their worlds, and it creates excitement because interstellar visitors like this one might bring materials that started life elsewhere. For example, models suggest thousands of similar objects fly through the outer edges of our system each year, but we only spot a few because they move so quickly and stay far away. With better tools like new observatories coming online, we could detect more soon, and each one adds to the puzzle of whether our sun's family is typical or special in the galaxy. The path of 3I Atlas traces back to the Sagittarius area, a region full of old stars and thick dust clouds, so it could even hold frozen bits from the early days of the universe itself. As astronomers watch closely with powerful scopes, the object already shows signs of waking up with a growing cloud of gas around it, and that makes everyone wonder what surprises it holds next. But how did scientists first catch sight of this cosmic wanderer? Scientists in Chile spotted 3I Atlas by chance through the Atlas telescope system, and that moment kicked off a fresh chapter in space history full of wonder. This faint speck appeared on their screens as a moving dot against the stars, so they quickly checked its path and realized it curved in a hyperbolic shape that screamed outside from beyond our sun's reach. Teams around the world jumped in to gather more data right away, and within a day they confirmed it as a true interstellar wanderer because its trajectory showed no signs of looping back like local objects do. Picture a group of experts huddled over computers late at night, piecing together numbers that prove this thing hails from another star system, and the buzz in the air grew as they knew time was short to study it before it raced away forever. Follow-up checks came fast from places like Arizona and Hawaii, and those early looks hinted at a fuzzy glow around the core that suggested cometary behavior rather than a plain rock. Observatories sent in reports to a central hub called the Daily Minor Planet, and by the next day, they had over 100 sightings from dozens of sites that locked in its status as the third such visitor ever caught. For instance, telescopes in the northern hemisphere captured slight extensions like a tiny tail starting to form, and that detail made hearts race because it meant the object might reveal its makeup as it warmed up closer to our star. Stats from those first hours pegged its brightness at magnitude 18, which is dim but trackable with big scopes, and its relative speed clocked in high enough to escape our gravity pull without a doubt. Digging into old records turned up surprises too, and astronomers found snapshots of the object from weeks or even months earlier that no one had noticed at the time. Data from sky surveys like Zwicky Transient Facility stretched back to mid-June 2025, while other systems caught glimpses as far as May when it lingered far out near Jupiter's path. These hidden gems helped map its incoming route more precisely, and they showed it approaching from a crowded star field that might have masked it longer. One example includes space-based views from a mission scanning for changes, and those added key points to plot its curve with an eccentricity way over 1, confirming it got kicked out from a distant home, perhaps by some cosmic tug-of-war. The find sparked global teamwork, as agencies in Europe and America geared up to watch its every move with their best tools. Size guesses started rolling in soon after, and sharp eyes from a famous orbiting telescope pegged the central body between about 300 meters and over 5 kilometers across, though most bets leaned toward the smaller end. That range stirred up chatter because a chunk that big could hold loads of clues about alien worlds, yet its modest scale meant we might miss finer details without close looks. As the excitement spread, questions popped up about what this wanderer really looked like up close. But what did those first clear shots uncover about its weird features? Those first clear pictures revealed that 3I Atlas is slowly developing a tail in coma, much like a sleepy traveler stirring awake in a new place. Powerful telescopes caught these changes as the object drew nearer to our sun, and the details painted a picture of something dynamic and full of surprises that kept watchers on edge. The coma formed a hazy envelope around the core, while the tail stretched out behind like a wispy trail marking its path through space. One set of shots came from the Gemini South Telescope in Chile on August 27, 2025, and they showed the tail extending to about 30 arcseconds, which equals roughly 56,000 kilometers in length. This growth happened because solar heat started vaporizing ices on the surface, and the images combined red, green, blue, and ultraviolet filters to highlight a colorful streak against a starry backdrop. For comparison, earlier views from the same site in July lacked this extension, so the difference sparked curiosity about how fast things were evolving. Data indicated the tail pointed away from the sun due to radiation pressure pushing dust particles outward, and this feature grew more obvious with better viewing angles. Another key view arrived from the Hubble Space Telescope on July 21, 2025, and it captured a teardrop-shaped cloud of dust streaming off the icy heart. The plume faced toward our star, suggesting gases escaped in that direction first, and measurements refined the nucleus size to under 5.6 kilometers across. This cocoon appeared reddish from irradiated organic materials in the haze, similar to other distant bodies we know, and it added a layer of mystery about what chemicals hid inside. Stats from these frames estimated dust release at 6 kilograms per second for tiny grains and 60 kilograms per second for larger ones, with small bits flying off at 22 meters per second while big chunks move slower at 2 meters per second. Infrared captures by the James Webb Space Telescope on August 6, 2025 added more depth, and they displayed a bright white center fading into shades of red, orange and blue across 3 panels. This glow hinted at carbon dioxide dominating the atmosphere, and the overall look confirmed the coma spanned wide enough to obscure finer details. Time-lapse sequences from Gemini showed the visitor gliding past stars with a trail that shifted colors under different filters, and this motion created a sense of urgency as the object barreled forward at high speed. Each visual clue built excitement, revealing a body unlike typical locals in our system, yet sharing some traits that were teased at galactic connections. As these visuals sharpened our view, experts noticed the visitor activating sooner than expected. But what caused this early stir in its behavior? Unlike any comet we know, 3I Atlas started waking up far beyond Jupiter's orbit, and this early spark of activity left scientists stunned with questions about its secrets. Most comets stay quiet until they swing closer to the Sun, but this visitor began releasing gases and dust when it was still over 900 million kilometers away, which is way farther out than typical icy bodies activate. This unusual behavior suggests something special about its makeup or past, and it sent researchers scrambling to figure out why this distant traveler was acting so lively. Observations from the TESS telescope, designed to hunt for exoplanets, caught this surprising activity as early as May 2025, and the data showed the object already forming a faint cloud of gas at 6.2 astronomical units from the Sun. Normally, comets need to be within 5 astronomical units to start vaporizing their ices, so this early start raised eyebrows among astronomers. The outgassing rate reached approximately 940 septillion molecules per second, and that's a huge amount of material escaping for something so far from solar heat. For example, a well-known local comet like Halley's only ramps up closer to 3 astronomical units, and this difference hints that 3I Atlas might carry unique chemicals that boil off more easily. Another clue came from the way light reflected off its surface, and studies showed a strange negative polarization in the scattered light, which is rare for comets and suggests unusual dust or ice properties. This quirk means the light waves twist in an odd way compared to what we expect, and it could point to a surface altered by eons of cosmic radiation or a different structure altogether. Measurements from ground-based scopes in Chile confirmed the activity grew stronger by August, and the gas release included unusual bursts that didn't match the steady patterns of local comets. These bursts suggested the object might have pockets of volatile ices trapped inside, and they could be popping open as it warmed slightly, even at such a great distance. The early wake-up wasn't just a fluke, and multiple observatories tracked it consistently, ruling out errors in the data. Scientists noted the object's brightness flickered in ways that hinted at irregular shapes or uneven venting, and this added to the sense that something extraordinary was unfolding. Each new report built anticipation, as this behavior could mean the visitor formed under wildly different conditions than anything in our system, perhaps near a hotter star or in a denser part of the galaxy. The odd activity kept everyone guessing about what drove it so far out. With such a strange start, what kind of materials could be fueling this cosmic traveler's early glow? Tests from top telescopes like JWST and SPHEREX uncovered that 3I Atlas carries a strange mix of chemicals, and its carbon dioxide-heavy makeup sets it apart from anything we've studied before. Most comets in our system release water vapor when they heat up, but this visitor's atmosphere contains far more carbon dioxide, which boils off at lower temperatures and explains its early activity. Scientists think this odd balance could reveal where it formed or what forces shaped it during its long journey, and the findings spark excitement about what else might be hiding inside this cosmic traveler. Data from SPHEREX in early August 2025 showed the gas cloud around the core had a carbon dioxide to water ratio of 8:1, which is one of the highest ever recorded for a comet. This ratio means for every water molecule escaping, 8 carbon dioxide molecules burst out, and that's wildly different from local comets like Hale-Bopp, which lean heavily on water. JWST's infrared scans back this up, detecting traces of nickel but no iron, which is unusual since most comets carry both metals. They also found small amounts of cyanide and a sulfur-oxygen compound called OCS, and these chemicals suggest the object might have formed in a region with intense radiation or near a star with different properties than our Sun. Another surprise came from the ice itself. An analysis revealed some of it is amorphous, meaning it lacks a crystal structure and traps gases like a sponge. This type of ice forms in super cold environments, so it hints that 3I Atlas could come from a distant, chilly part of its home system, perhaps near the edge where carbon dioxide freezes easily. For example, the object's low levels of carbon chain molecules, which are common in our comets, suggest it faced conditions that burned those compounds away over time. Roughly 60% of its outgassing comes from carbon dioxide, and that high share could mean it formed close to a boundary where this gas turned solid, locking in a snapshot of its birthplace. The chemical mix doesn't just tell us about its past, and it raises big questions about how planets and life-forming materials spread across the galaxy. Some scientists guess it might carry organic compounds that could seed life elsewhere, and that idea adds a thrilling layer to its story. Each measurement feels like peeling back a curtain on a far-off world, and the strange makeup keeps researchers hooked on what it might reveal next. No one expected such a wild cocktail of elements, and it makes this visitor feel like a puzzle piece from a distant cosmic game. With its chemistry laid bare, where is this strange object headed next? With a path that twists through our solar system rarely and surprisingly, 3I Atlas is zooming past planets on a route that feels almost too perfect to be chance. Its retrograde orbit, tilting sharply at 175 degrees against the flow of our planets, makes it stand out, and its close brushes with multiple worlds create a sense of urgency to catch every moment. The object's journey is a fleeting chance to study something from another star, and its bold trajectory keeps everyone guessing about its purpose or origin. Calculations show it will swing closest to the Sun on October 29, 2025, at just 1.4 astronomical units, placing it between the orbits of Earth and Mars. Before that, it will zip by Mars on October 3rd at about 30 million kilometers, and then approach Earth in December at 269 million kilometers, which is roughly twice the distance from our planet to the Sun. By March 2026, it will glide near Jupiter, and these close encounters have a combined probability of less than 0.005%, making the path seem almost choreographed. For example, the odds of passing so near 3 planets in one trip are slimmer than winning a lottery, and this rarity adds a thrilling edge to its visit. The orbit also shows a slight wobble that doesn't fully match gravity's pull alone, and scientists measured a tiny extra push of 4.92 times 10 to the negative 6th meters per second squared, hinting at forces beyond our normal understanding. This nudge could come from gas jets or something stranger, and it makes the object's path even more intriguing. Its steep incline and backward motion suggest it entered our system from a direction tied to the galaxy's dense core, and some experts estimate it might have been flung out by a massive star's gravity long ago. The trajectory aligns with the ecliptic plane in a way that happens only once in 500 cases, and this precision stirs questions about whether nature alone could plan such a course. Telescopes tracking its motion confirm it will be hidden by the Sun's glare for 7% of its closest approach, so scientists are racing to gather data before it slips from view. Spacecraft near Mars might catch a glimpse in October, and NASA's Juno probe could snap images near Jupiter later, but these windows are tight. Each point on its path feels like a checkpoint in a cosmic race, and the strange alignment keeps the scientific world buzzing with anticipation. With such an odd path, Could someone out there have sent this object our way on purpose? A bold claim from Harvard's Avi Loeb suggests 3I Atlas might be an alien spacecraft, and this wild idea has set the science world ablaze with debate. Loeb, a well-known astrophysicist, argues the object's strange traits don't fully match a natural comet, so he estimates a 40% chance it could be a probe sent by an advanced civilization. His theory hinges on odd clues that don't add up easily, and it's got everyone talking about what this visitor might really be. Loeb points to the object's bright halo, which shines with a power close to a gigawatt, and he says that's like a nuclear power plant's output, far beyond what natural comets produce. For example, a tiny black hole would only emit 20 nanowatts, and friction from space dust can't explain the glow either. He also notes the object's path aligns too neatly with our planets, with a 1 in 500 chance of matching the ecliptic plane so closely. This precision suggests it might use a reverse Oberth maneuver, a trick to slow down near stars, and Loeb speculates it could drop smaller probes with a thrust under 5 kilometers per second to scout our system. Despite the buzz, most scientists lean toward a natural explanation, and they argue the object's gas emissions and icy core fit a comet's profile better than a machine's. No radio signals have been detected after sweeps by telescopes, and that absence weakens the alien tech idea. Still, Loeb's earlier theories about Oumuamua stirred similar debates, and his bold stance keeps the possibility alive. About 60% of experts surveyed in a 2025 poll dismissed artificial origins, but the remaining 40% admitted the anomalies are hard to explain fully. The object's dusty front, which Loeb calls possible debris from a long trip, adds to the mystery, and it makes you wonder if we're missing a bigger picture. This debate pushes us to think bigger, and it shows how one object can challenge everything we assume about space. If Loeb's right, the stakes for humanity just got higher. But what does this visitor mean for our place in the galaxy? Whether it's a comet or something more, 3I Atlas opens a window to other star systems, and it could carry clues older than our own sun. This visitor lets us peek at how planets form far away, and its ancient materials might reveal secrets about the building blocks of life across the galaxy. Picture a tiny piece of another world zooming past, holding answers to questions we've asked for centuries, and its brief visit feels like a once-in-a-lifetime chance to learn something huge. The object's journey ties us to the bigger cosmic story, and it pushes us to rethink our place among the stars. By studying its makeup, scientists can compare it to our local comets, and this helps figure out if water-rich worlds like Earth are common or rare elsewhere. For instance, its high carbon dioxide content suggests it formed in a colder, different environment, and about 15% of known comets show similar traits, but none match its extreme ratio. This odd chemistry could mean it carries organic molecules, which are key to starting life, and that idea sparks wonder about whether such materials seeded planets long ago. Future missions like the Interstellar Comet Explorer plan to chase objects like this, and they could collect dust samples to confirm if these visitors spread life's ingredients across space. New observatories like the Vera Rubin Observatory will spot thousands of similar objects yearly, and estimates suggest up to 10 interstellar visitors pass close enough to be detected each year. This flood of discoveries could rewrite our understanding of how solar systems work, and 3I Atlas is just the start. NASA's Juno spacecraft might catch a glimpse near Jupiter in March 2026, and that could add fresh data about its surface or gases. The European Space Agency's Comet Interceptor is also ready to launch quickly for the next visitor, and such missions promise to unlock details about distant worlds we can't yet reach. Every fact we gather feels like a step closer to understanding our galaxy's history, and the possibility of ancient materials from the Milky Way's early days adds a thrilling twist. 3I Atlas continues its solitary journey back into the depths of interstellar space, leaving behind a transformed scientific landscape and a profound legacy. This third interstellar visitor, with its enigmatic early activity, unusual carbon dioxide-dominated chemistry, and perfectly aligned trajectory, has provided humanity with an unprecedented peek into the construction plans of distant solar systems. It has challenged our assumptions, fueled thrilling debates about artificial origins, and ultimately served as a powerful catalyst for a new era of exploration. The mission concepts it has inspired, like the interstellar comet explorer, are no longer mere dreams but urgent goals. The powerful message of 3I Atlas is one of connection and hope. We are not isolated, but part of a vast, dynamic, and shared galactic ecosystem. These cosmic wanderers are not just threats or curiosities. They are messengers, carrying the very ingredients of possibility between the stars and reminding us that the next great discovery is always on the horizon, waiting for us to reach out and grasp it.